Choose a picture without any bacteria. Trick question. All have bacteria on it. Just not in the same quantity. Pretty obvious, you might say, and it is. But what is less so is that they are not of the same quality either. In this sense, bacteria are like animals, each living in and on environments ideal for them. Alright, they are pretty common, but if you are clean enough and wash your hands, well, not exactly. Bacteria are everywhere, or almost everywhere. They can thrive even in places like your stomach, the ice in Antarctica, the Marinara Trench, or in fuming hydrothermal vents, in places where water freezes or boils and where even iron dissolves. Excuse me. But really, what are they? In a way, they are very much like our own cells. But if you look at them more closely, they also are radically different. They are monocellular organisms, meaning that their body only consists of one unit, a cell. They also are prokaryotes, which sounds very fancy until you learn that it's just Greek, or rather geek, am I right? For before nucleus, referring to the fact that they did not evolve to have a membrane-bound nucleus. They've got DNA, ribosomes, proteins, just like us. But their DNA floats freely inside their cytoplasm. That's their cell goo. While ours is neatly packed in a nucleus wrapped up in 23 pairs of chromosomes. Fancy. Their insides work differently too. We've got parts they don't, sure, but more importantly, they've got some parts we don't. The big one, a cell wall. It's a tough outer shell that protects them and can block drugs from getting inside. Not all bacteria have one, but most do, and that little wall is going to matter a lot later. Where our beef starts with them is their metabolism. As all living things, they also have to eat to stay alive. There are some that use the energy of light to power themselves, and some use chemical energy for the very same purpose. Some of them use inorganic substances, like iron or manganese, and some use organic compounds, like, well, you. Some even go as far as to manufacture toxins and enzymes to help them colonize your body, or to break down proteins, cells, and other organic structures that would be meant to harm them, or ones they can feed on. Mind you, these are structures you were still using. Pretty rude of them. Some are even able to live on the surface of, or inside your cells. But not all of them are like that. There are bacteria that live inside you and are not pathogens, as they do not cause infections. Or more commonly, they are opportunistic or facultative pathogens, meaning they only affect you if you are immunocompromised, or if they get in places that they are not supposed to. These are often referred to as good bacteria, commonly also being beneficial for the host, breaking down waste that we can't into things we can reuse, making nutrients we are not able to, and taking up space from dangerous ones. New invaders have a distinct disadvantage in this turf war, as they have to compete while our immune system is hellbent on beating them up as much as possible. Now that we know enough of them, let's talk about something more practical. How to defend yourself and your home from the harmful ones. Fortunately, those mentioned before are outliers, and most bacteria are not that resistant to boiling, freezing, treatment with acid, base, or any other physical trauma. As those able to harm you are usually the ones that fancy living in you. By making their surroundings distinctly unlike those of your body, you can seriously inconvenience them. Depending on the wished outcome, you can call these treatments sanitization, that is meant to reduce the number of microorganisms on the surface to a safe level. When disinfecting, you aim to destroy most or all microorganisms, except for the very resistant bacterial spores which are like escape pods for the germ. Although the ability to form spores is not that common, there are some pretty devious little bastards that can survive this way, like the Clostridiaceae family. The members of which can cause tetanus, also known as lockjaw, botulism, its polar opposite, and other, less famous illnesses. And that's why we need our third option, sterilization, when you want to make something completely devoid of any life, including those nasty spores. These are options when treating objects or even wounds, but they are not so much of a good idea when the germs are already inside you. As frying the illness out of someone is, yes, technically viable, but cannot exactly be called patient-focused healthcare. So in reality, if this has already happened, there are three main ways to go about it. The most famous one is antibiotics. They are cleverly made drugs based on recipes stolen from microorganisms that have been fighting bacteria for eons. The principle behind the idea is that these germs have molecular mechanisms and proteins different enough from ours that inhibiting them does not mean inhibiting our analogous processes, but even better if we don't have one to begin with. Which is the case for our very first commercially available antibiotic, penicillin. This drug works by destroying their ability to synthesize their cell wall by binding to the creatively named PBP, or penicillin binding protein. Now finally, that really is a name I can wrap my head around. PBP would otherwise be busy knitting little pieces of their walls together, but this time it is just floating around, bound and useless, as the cell crumbles around it. But the fact that antibiotics need a process foreign to the body to inhibit also means they only work against bacteria and not against viruses, which are more like little envelopes with instructions for our cells to ride them till they combust from stress and inhumane working conditions, thus lacking any processes we could inhibit without poisoning ourselves. We used to always use these drugs when we treated something bacterial in origin, as they are pretty effective most of the time and rarely have any adverse effects on the patient. But it turns out that there are cases when risks outweigh the benefits, and everyone is better off, excluding the germs of course, if we just let the patient's immune system handle the infection. Why? Three big reasons: allergies, rising antibiotic resistance, and dysbiosis. That's when your body's good bacteria get wiped out along with the bad. Since bacteria look pretty similar, antibiotics aren't great at telling the difference between friend and foe. Thus the good guys often get hit too, and the survivors, good or bad, start scrambling to take over, which can lead to trouble, especially if the issue was already caused by some microbial imbalance, like it is often in cases of salmonellosis, traveler's diarrhea, and many other illnesses with similar symptoms. The third option is bacteriophage therapy. In this case, viruses, specialized for the bacteria causing the infection, are used to eliminate them. It nowadays is usually taken as a last resort under compassionate use protocol when conventional antibiotics have already failed because of antibacterial resistance and the patient is in life-threatening condition. Fortunately, as of today, many other uses are being tested and developed for it, as it is a great tool for combating antibacterial resistance without taking any unnecessary risks.